Hello, so today I'm looking at M3 International A-Level January 2014. This is question 4. Figure 1 shows a sketch of the region R bounded by the curve with equation y equals e to the negative x, the line x equals 1, the x-axis and the y-axis. The uniform solid S is formed by rotating R 2 pi radians around the x-axis. And it says show that the volume of S is this. So to work out the volume of revolution, then I need to integrate, do pi multiplied by the integration of y squared dx. And so in this case, I had the equation of y here. So I will do pi multiplied by the integral of this squared, and e to the negative x multiplied by e to the negative x will make e to the negative 2x. And the limits will go from 0 to 1. So integrating this, I end up with pi outside, e to the negative 2x, and then I differentiate negative 2x, which makes negative 2, and divide by that derivative. Okay, and I need to evaluate that from 0 to 1. So when I pop 1 into here, in fact, I'll take the negative 2 outside. So I end up with pi over negative 2, and so I will end up with e to the negative 2, subtract e to the 0, and e to the 0 is 1, and so I will end up with negative 1 times this, which makes just pi over 2 multiplied by 1, and I can basically move that negative there so that I have positive pi over 2 outside, and so here I will have negative e to the negative 2. And this, fortunately, agrees with the result that they wanted, so as required. Okay, so part B. Then it says, find in terms of E the distance of the centre of mass of S, which was the solid, from O, and this is worth 7 marks. So in order to work out the position of the centre of mass of a volume of revolution, then I can use the equation pi y squared x dx equals pi x bar integral of y squared dx. Now, I just worked out this, but without the x bar. So in fact, on the right hand side, I can just pop the result that I got together with this x bar. So I have x bar multiplied by this result here. Okay, and now for the left hand side. So here I have pi, and I integrate. It's very similar to what I did before. So here I know I'm going to end up with e to the negative 2x, but now I have this x in here as well. And once again, I'm integrating from 0 to 1. Okay, so I can just tidy this up a little bit. I can see I've got pi on both sides, so I can cancel that already. And then I just need to do this integration on the left-hand side. So you might recognise from P4 that this is an integration by parts integral. So to integrate x e to the negative 2x, let's see what happens. I shall make u dash will therefore be 1, v dash will be e to the negative 2x, so v would be this integrated, so e to the negative 2x over negative 2. So now the integral of this times this is the integral of, sorry, I get this multiplied by this, plus the integral of this times this. And so this I'll just leave it as it is, x over 2 e to the negative 2x. And now integrating this makes e to the negative 2x, and then again I divide by negative 2, so I end up with a negative 4 on the bottom. So if I'm going to evaluate this from 0 to 1 then, so I'll come back to here, then so I'll just leave it so that you can see that. So on the right hand side, then I have x bar over 2, 1 minus e to the negative 2. And here I have this evaluated from 0 to 1. So I have negative x over 2 e to the negative 2x plus e to the negative 2x over negative 4. And in fact, this would be a bit nicer because I can see I've got this. I should take that out as a common factor, and I can take the 2 out as well, and a negative. And that will just make it a little bit nicer. So I'll just rewrite that. E to the negative 2x, negative over 2, multiplied by half minus x. So this times this makes that, and this times this, whoops, that's a plus, this times this makes this. Okay, and so this needs to be evaluated from 0 to 1. Okay, so when I pop 1 into here, then I end up with 1 plus a half, so I end up with 3 over 2 multiplied by negative e to the negative 2 over 2. And when I pop 0 into here, I end up with half times negative e to the 0 over 2. And e to the 0 is just going to be 1. So I end up with a half times a half there. Okay, I could get rid of a half by doubling everything. And let's just try to tidy this up. So I have, I take a half out, and I end up with 1 minus 3 e to the negative 2. And to end up with x bar on its own, I can divide this by this. So I end up with 1 minus e to the negative 2, like that. Okay, so that part of the question is worth 7 marks. Altogether, you have 10 marks. I hope you found that solution helpful. Do click like if you liked it, and all the best of luck with your studies.